Okay. The topic of today's lecture is reliability and validity in assessment. There is a reason why alphabetically I have placed R before V, and also you'll notice that I've placed this diagram on every slide. There are 8 functional slides, and the ninth slide is on references. And on each and every slide, I've placed this diagram, and there's a reason behind it. Now, what is assessment? Assessment is a method to collect data about learning. It can be an exam, it can be multiple choice questions, anything that collects data about how much a student has learned. And what is the value of assessments? The value of assessment is that it guides teaching practices, and assessment can also be used to evaluate teaching programs. After the end of this course, we'll be asked to give feedback on how we like the course, okay? And so uh, an assessment is made on how much we learned and how much we like the course, and so that's what assessment is. Assessment can be in the form of standardized tests, unit, chapter, lesson tests, matching, true and false, quizzes, projects, presentations, writing tests, etc. Okay, so this is the way how assessments can be taken. And what does assessment do? It allows data-driven instruction through student performance data. For instance, I'm a student in this course, and the assessment of this video will allow my instructor to reach some conclusions as to how I performed. Okay, but the $1 million fact is an assessment must be reliable and valid to allow conclusions to be drawn from it. Okay, so note reliability and validity. R is coming before V. So an assessment must be reliable and valid to allow conclusions. Now I'm not going to explain this other than when I reach the 7th or 8th slide. This is in the form of a graph. Okay, this is reliability, validity. And note high reliability, high validity. These are dartboards. The darts have all fallen here. High reliability, darts have all fallen in one corner. Validity, high validity, the darts have reached within the target. Low validity, the darts are missing the target. So in any assessment, A, assessment must be reliable and valid to allow reliable and valid conclusions. The test can be anything, but the conclusions drawn must be reliable and valid. Okay. Reliability. Does the test measure consistently? This is diagram of a dartboard. Reliability, does the test measure consistently? Is the inference we draw consistent? Okay. Now note that this is the zone of, suppose reliability increases from here to here and validity increases from here to here. Okay. These are high reliability. What's happening? The darts are consistently following in one place. The darts are consistently following in one place. Okay. Reliable, but are they valid? But is the inference valid? See, uh, validity here. This is where does it fall within the target? Validity. How closely does the test measure what it's supposed to measure? Now, what is this? This target practice dart throwing area measures the person's ability to throw darts correctly. Okay. Now, note that he's throwing the darts. In this place, the darts are going off the board. In this place, the darts are missing the target, but they are very close together. So this validity, that is the validity, that's the uh, dart thrower's ability to use this board to score correct points is not being measured at all. He's throwing it all over the places. So the very test is invalid. Okay. Validity. How closely does it measure what it's supposed to measure? It's not measuring his ability. Reliability. Does it measure consistently? Here it is measuring consistently. As I said before, the more we go on through the slides, the more it'll be easy for you to remember this. So what are the objectives of this instruction? It's to be able to assess whether the assessment is valid, reliable, and fulfills four criteria. Now, what's the criteria? We'll get to the four criteria in the next slide. Again, there is this thing that if there are two things that you will take away from this is mastery of this diagram and mastery of this sentence. That is, a test can be reliable but not valid. A test, if valid, must be reliable. And here you must remember that R comes before V. Let us say we are discussing seniority. So the letter R is less senior than the lesser letter V. This is just imagination, but let us suppose the alphabet A to Z represents a list of seniority, where the closer an alphabet is to Z, the more senior it is. So let us say that R is less senior than V. So a test can be reliable, but the letter V can override it, but it may not be valid. But if a letter V is valid, it's senior and can override R. So a test, if valid, must be reliable. There's a method to my madness, okay? As we go along this assignment and as I go along teaching, towards the last few slides, I'll tie this all up. But for now, just remember a test can be reliable but not valid. A test, if valid, must be reliable. R is less senior than V. V is senior to R. V, a valid test can override this, but this can't override that, okay? A test can be reliable but not valid. A test can be valid and it must be reliable, okay? So I said there are different kinds of assessment. So what kind of assessments are there? There are selected response assessment. That is where you choose a particular answer. That's in MCQs, true, false, match the results to the question. Number two, another type of assessment is constructed response, has a prompt. That is, you construct your answers to the prompt. Write an essay on the rain falling outside my window. So the prompt is the rain falling outside the window, and the essay is to write an essay on the assignment is to write an essay on the rain falling outside my window. Okay. What are the four principal purposes of assessment? First purpose is, of course, certification. To assess the levels of achievement, perhaps to give a license to practice. For instance, the USMLE, the PANS exam, the PANRE are all certify that this medical student is fit to be awarded a certificate. In the case of the USMLE, it's a certificate to practice medicine. In the case of PANS and PANRE, it's a certificate to become a PA. Okay, certificate. So one of the primary purposes of assessment is certification. The another purpose of assessment is to see how much a student has learned. Now, certification assesses is as an assessment of learning. You've learned so much, we certify you. Now, in assessment as student learning is where it's for and as learning. The questions can be phrased so that the student learns more. Okay. And the assessment for learning, that is to say, the student is also learning, and also um, the very question is concocted in a way that the student learns from the question. Okay. Quality assurance. Now, assessment can be of quality assurance. That is, the stakeholders can gauge relevance of standards. Now, for instance, as you'll see in another example later on, grocer keeps his perishables in a certain fridge. Food inspector comes and measures the temperature of the refrigerator to make sure that the standards that the grocer is supposed to keep his food at is maintained. That's so assessment can be of quality assurance. Okay. Lifelong learning. This is where the assessment encourages you to learn more. Okay. BA to MBA to doctorate in teaching. All these assessments can inspire a person to learn more. So there are four principal purposes of assessment, as I said: certification, for student learning, for quality assurance, and for lifelong learning. Okay. Now, data-driven instruction. The data we collect from the assessment further guides programs to follow and the practices that we follow. Okay. For instance, the data that the USMLE examinee, PANS examinee, PANRE examinee, the data that they generate because of their answers alerts the paper setters or alerts the boards as to how the examinees are learning and whether the questions they are asking are valid or not. Okay, that's the programs and practice. Okay, now we've harped on the term of theme of reliability and validity. So again, let me tell you, the inferences, the an instructional program can be reliable. The assessment can be reliable but not valid. But if the assessment is valid, it must be reliable. R comes before V. V can override R. If a assessment is reliable, it may or may not be valid. If an assessment is valid, it must be reliable. Okay, now what is this reliability? Reliability is actually consistency. See, these darts are all falling in a group. These darts are all falling in a group. This guy is the dart thrower is consistent. R and C, consistent. At the eighth slide, seventh or eighth slide, I'll give you a mnemonic which will make you remember what reliability and validity is. But for now, there's a method to my madness, I assure you. Just listen to what I'm saying. Reliability is consistency. If a person is reliable, he's consistent. Okay. Now, what are the forms of consistent in assessment? There is stability and test, retest, consistency. Okay, reliability. That is to say, if the same test is administered to a person over and over and over again, the person will come up with the same answers. Okay. Now there's another form of reliability called alternate forms and equivalent forms. Um, examination form given to students in Texas. Suppose another form of the same exam is given to students in Arizona. Okay. Uh, One form is labeled Form X and Form I, but they are geared to test the same thing. You'll find that alternate forms and equivalent forms will generate the same answer. That is consistent. For instance, the GRE exams, their tests can be administered in the country of India at the same time as they're being administered in Czechoslovakia. But the inference that the examiners will gauge from the results should be the same. Okay. Now there is another form of reliability called internal consistency. Okay. Now suppose in this case, what we do is we first make a whole list of questions, say 1 to 100. Then we take the odd numbers and give it to one student, take the even numbers and give it to another student. The two halves of the test must actually generate similar results if the examiners are of equal competency. Okay. Now, internal um, consistency also means that if we give us students a math test for number sense and logic, we have to make sure that the math test is actually measuring logic and number sense and not the math student's ability to understand or read correctly. Okay. Um, so the test must be geared so that it must be internally consistent. Two halves must generate the same results. Also, that a long math question for math sense and logic and number sense, mustn't actually end up as a test of the student's reading ability. Okay. Now let's discuss the first thing. I give you a brief outline: stability, reliability. So the same test given over a period of time must give rise to the same results. And for instance, the same test given to students of similar capacity, one student takes it on a Monday and the other student takes it on a Friday, the results must be consistent. Now, for instance, IQ tests. IQ tests don't usually change over time. Or they change a few points here and there, except where the student has received a brain injury, motor vehicle accident, he develops a brain injury, and his IQ is noted to drop. Okay, because there's some pathological process which has destroyed his IQ. So now IQ is one of the most stable examinations possible. Okay. Now, to further explain what alternate forms reliability or equivalent forms reliability is, when multiple versions produce the same results, example, form X in Texas of the GRE exam, one form in the GRE exam given in Texas will be equal to the uh, similar test, the GRE test given in Arizona, and the similar test given in India. Okay, so all these should reliably give you a means of measuring the student's capacity. Internal consistency. Suppose language arts. Okay, language arts testing, reading comprehension, spelling ability, punctuation skills. We must make sure that it's not examining anything else. For instance, a language arts paper on reading and spelling ability, a language arts paper on reading. Suppose it's just a test of reading. It can't be a test of spelling ability or punctuation skills at the same time, unless the assessment is geared to that. Okay. So if you're testing for a reading comprehension in a student, don't give in questions which are testing the student's spelling ability or punctuating skills, and so on. Okay. Also, there's internal consistency, split half reliability, where suppose you give one student the odd numbers of a battery of questions and the other student even numbers of the same battery of questions. The results should be consistent. Okay, for instance, these are questions. Suppose we are asked to make a customer service questionnaire. Okay, then the three. Suppose we bought something from online store, and the online store now gives us a, a questionnaire saying, "Are you satisfied? Will you recommend our service to others? Will you give us a favorable online review?" Three questions for customer service. We have bought something online, and the store gives us three questions. Are you satisfied with our service? Will you recommend our service? Will you give us a favorable online review? And suppose the questions are from a series of five, that is highly satisfied to highly unsatisfied, in between, highly satisfied, satisfied, non-committal, not satisfied, and highly unsatisfied. Okay, so we are given the choice of five answers. Now you find that the person actually, if he's satisfied, you generally expect him to recommend, and generally expect him to give us a favorable online review. But if the answers come not satisfied, but I'll give you a favorable online review, I'm very satisfied, but I won't recommend you. That is not internally consistent. So there's something wrong in either the service or the way we have worded the question. Okay, where the or the way we have served the person actually, because inference we draw, a person can't be satisfied and then say, I don't want to recommend it to anybody, or I'll give you an unfavorable online review. So what I'm trying to drive at is that it must be internally consistent. The assessment must be internally consistent. The inferences that we draw must be consistent. Okay. Inter-rater reliability. Now, what kind of reliability is this? Now, the inter-rater reliability is when two examiners are given rubrics, and if they're told to examine the same person's results, one can't give him 100%, the other can't give him 50%. Okay, so the rubric must be consistent, so that the raters are consistent, the answers are consistent. It's called inter-rater reliability. Okay. Now we reach. There is a way of measuring reliability actually. Okay, it's called a reliability coefficient, and it's expressed as a number between 0 to 1, where R means no reliability and 1 is perfect reliability. For correct evaluation type of test, type of reliability estimate reported should be considered. This reliability coefficient should be considered for correct evaluation of the type of test. See over here, there is a certain uh, rubric. See, if the reliability coefficient value is below zero point 0.7, may have limited applicability. You can't use it. If it's between zero point 0.7 to 0.79, it's adequate and so on. Okay, so this is the reliable. This is a means of measuring whether an assessment is reliable. Okay. Now let's go to this slide again. See the high reliability is where they are clumped in one position. Low reliability when they aren't clumped. Okay, so the main thing is that reliability means does it measure consistently? Does it measure consistently? Now we reach validity. What is validity? How closely does it measure what it's supposed to measure? Now regarding this this particular picture I've shown here, notice that the dart thrower over here is chucking his darts. They are completely missing the target. So it's haphazard. It's not actually measuring what it's supposed to measure. Now this dart thrower, either because of the wind conditions or something, these darts are being blown off and it's going. So it's not measuring consistently. It's not measuring his the dart thrower's ability. Okay, either because of some condition is upset here, where the darts thrower is chucking it, throwing his darts all into one corner, and he's trying his utmost to chuck it at the same place, but probably the wind is blowing it off. Okay, over here too. Okay, so basically it's not measuring what's meant to measure. It's not measuring the skill of the dart thrower because the wind is blowing his darts off. Validity. How closely does it measure what it's supposed to measure? So there are also types of validity. Uh, there's a content, constructability, predictability. And I'm going to explain all this in the next few slides. The types of validity are content, construct, and predictive. So to recapitulate, does it reliability means does it measure consistent? Reliability, consistency. Reliability, consistency. RC. RC. And there is a reason why I'm saying RC. There's a mnemonic I will discuss at the end of this slide, where at the end of these slides, which will make sure, I hope that you'll never forget. Validity. Does it measure what it's supposed to measure? So validity again is three types: content, construct, and predictability. Now what is this content validity? Content validity. Do the assessment items correctly represent the areas that the assessment is designed to measure? Do the assessment items correctly represent the areas that the assessment is designed to measure? Now, for instance, two students, one in Nepal, the country called Nepal, just to the north of India, and one student in Iowa. They have to graduate from 7th grade. So a science test is given to a Nepalese student in the Nepalese language. The same test is given to the 7th grader in Iowa. And he said, well, I can't read Nepalese. The Nepalese language is a different script. So is the test valid? No, it's not. Because the poor student can't understand a word, the student in Iowa can't understand what this Nepalese language is. Though they are both from the 7th grade and probably they've both been taught the same material, but it's not working. For instance, um, suppose there are math scores in the 7th grade of 10 units. Now we've taught the student only the first 2 units. We can't ask the student questions from the third and fourth unit. Okay, it's not valid. It won't work. It's completely invalid, the test. So now we then we ask the student to add and subtract fractions. Now we are giving the student, we have taught the student how to add and subtract fractions of with the same denominator. We can't give him fractions of different denominators. Okay, that's going to confuse the student totally. So basically, the content must be valid. The content must measure the content must measure what we've taught the student to do, not something that we haven't taught the students to do. Now, what is a construct validity? Does the test measure the characteristic quality of construct it is designed to measure without assessing something else, even inadvertently? Okay, now a third grader is given a task to measure the perimeter of a rectangle. The language can't be at a ninth grader's English level, okay? The language of the test must be at a third grader's level. So that is what the question must be constructed so that it's at the reader's ability. Now, predictive validity. How well the assessment results predict success on a related future criteria. We predict how well the student will do later on. See, suppose a student has done geometry 1 in 1 year. We can reasonably predict that he might do well in geometry 2 next year. A student who is coming first in all classes from 1 to 5, from all grades from 1 to 5, we can reasonably predict that this guy is a very studious guy. He'll do well in 6th grade. In fact, SAT, ACT aptitude tests for high school students correctly predict academic success in college, and that's why they are called scholastic aptitude test. Okay, SAT, scholastic aptitude test. These are achievement tests. I mean, and they can predict exactly how well a student will fare in college, ACT and SAT. Okay, now as the slide on the promised memory aids. See, a test can be reliable, but it can still not be valid. Note that R in the alphabet list is coming before V. P, Q, R, S, T, U, V. R comes before V. However, if a test is valid, it is reliable. Now, how do you commit that to memory? Suppose the alphabet is arranged in an increasing order of seniority. So R is junior to V. So V can override R. So a test can be reliable but not valid. But because V is senior to R, if a test is valid, it must be reliable. Memory aid. R before V, P, Q, R, S, T alphabet. So if V is okay, R must be okay. Okay. So V overrides R. So just remember, if a test is valid, it must be reliable. However, reliable tests may or may not be valid. These tests are reliable. And notice that they are falling within the target range. Therefore, they are. Uh, uh, see, these two tests are valid. Consider high validity. They are falling within the target. This is low validity. They are not grouped around the center. The center is what we take as the validity of the dart throws aptitude. Now the wind is blowing this off course, and this is also off course. So it's not a valid test at all. Validity is less. Validity is more. Now this is a little mnemonic that I processed. See, precise root canals done in the alveolar bone. Reliability is equivalent to precision, is repeatable, consistent. Okay, reliability, precisely grouped around a particular spot. Precise, reliability, repeatable, consistent. Consistently throwing the darts at one particular point. Repeatably throwing the darts at one particular point. Reliably throwing the darts at one particular one. Precise. But to be accurate, accuracy is validity and efficiency. Precise root canals done in alveolar bone. I've done this. I've given the example of an alveolar bone because my practice belongs to the head neck. I'm an ENT physician assistant. Okay. Now the alveolar bone. See, this is the alveolar process of the mandible. This is the alveolar process of the maxilla. So root canals must be done in this bone. In this bone. Okay. So precise root canals are done in the alveolar bone. These first four in red are precision, reliability, repeatable, consistent. They're all describing the reliability. Accuracy, validity, efficiency are all describing validity. Accurate, valid, efficient. Over here, these initial alphabets are describing reliability. Precision, reliability, repeatable, consistent. Accuracy, accurate, valid, efficient. Okay. Validity here, accurate, valid, efficient. Precision, the reliability here, precise, reliable, repeatable, consistent. Okay. This is the alveolar bone. So precise root canals are done in the alveolar bone. Precision, reliability, repeatable, consistent, accurate, valid, efficient. Accurate, valid, efficient. This is high reliability, low validity because it's off center. Here it's highly reliable, highly valid because all pointed in one direction. Okay, all clumped around this. This is low validity because it's being blown off. This too is low validity being blown off. This is high validity because these are all tending towards the center, being clumped around the center of this. Okay. So again, as I was saying, precise root canals done in alveolar bone. A mnemonic to remember reliability and validity. Reliability, precise, reliable, repeatable, consistent, and validity, accurate, valid, efficient. Of course, this, if you remember anatomy classes, this is the alveolar. These are the alveolar processes of the mandible. This is the alveolar process of the mandible. This is maxilla. Okay. And this is that famous dartboard uh, example. Very aptly drawn in a graphical form. Here, this is validity is increasing, reliability is increasing. This is a dart thrower is throwing his darts. They're all going off course. Low validity, low reliability. His chucking is not reliable because probably the wind is blowing it off, and therefore the very test isn't a valid test. Here, he's still throwing, but it's clumping around at one particular place. But it's still not valid because the wind is blowing it off. Okay. Over here, validity is high. It's all clumped around this target. It's all clumped around the inner target. But reliability here is low because it's still being blown off, and where reliability is high, it's going point point right in the center. So here again, if there's one thing that I want my students to take away, it is this particular diagram: reliability, constructability. Okay, reliability, validity. Please uh, remember this diagram. If a test is valid, if this bullseye is valid, the thrower must be able to reach the center for it to be valid. It can't be blown off here and there away from the center. See, the validity here, it's all clumped around the center. But reliability, here it's high reliability. Okay, because you can reliably expect the person to chuck it at all in one place. This is reliability but not valid. It's not getting at the center. It's not getting at the center. Okay. So just if you just remember this and understand this, of course, here it's being blown off course, and it's the dots are falling way off the chart too. So it's neither valid nor reliable. Here he's being reliable, but it's not valid because we don't know if the test is actually what is causing this to go off course. Here it's not only measuring his ability to hit the bullseye, he's landing it in the right place. High reliability, high validity. Yes, we can give him a certificate saying that he's the dart master, dart throwing master. Here, he's throwing it at around the center, but is it reliable? No, he's not throwing it reliably. Okay. Again, a test. This dartboard and this little sentence. A test can be reliable but not valid. A test, if valid, can be reliable. These are the two things I want you to leave this little teaching episode with. These two sentences. The bullseye, this target practice, and this a test may be reliable but not valid. A test if valid must be reliable. And the easiest way, as I said, to remember it is to think of the alphabet as arranged in list of in seniority, with Z the most senior and A the least senior. So R S T U V, V must be senior to R, can override R. So if it is valid, it must be reliable. If it's reliable, may or may not be valid. Okay. So R cannot override V. V. Now let's discuss a few examples. We are in a grocer's shop. The grocer keeps his perishables, that is chocolates, meat, food matter, in a refrigerator, which, according to the grocer's temperature, it's fantastic. It's uh, storing everything at freezing point. But the food inspector comes and measures, saying it's no, it's about 10 degrees, 10 degrees higher than it should be. It's 10 degrees lower. My thermometer is showing 10 degrees centigrade. Yours is showing 0 degrees. Okay. So what's happened here? The grocer's thermometer is reliable, but it's not valid. It's measuring the temperature, as you see, but it's way off course. It's measuring the temperature consistently. Okay. But it's persistent, reliable. Yeah. It's all there, consistent, reliable, but it's reliable at the wrong temperature. Okay. It is. It's not measuring what it's supposed to measure. It's not measuring the correct temperature. It's supposed to measure the correct temperature. It's not doing that. Even though it's reliably measuring the wrong temperature. We can reliably expect it to measure the wrong temperature. But the food inspector comes and says, hey, your temperature is way off course. I have two very old weighing machines. As I said, they are 26-year-old. They are made of spring, of course, and they show my weight at 200 pounds. Then I bought a digital bathroom scale, brand new, which measures it at a more acceptable 185. Okay. So what's happening? This is my 26-year-old spring bathroom scales are reliably, consistently, persistently measuring my my weight at 200 pounds, which is completely wrong. It's not valid. And my new bathroom scales are high reliability, high validity. For a brief summary, so what is assessment? Assessment is collecting data about learning. Assessment guides teaching practices. How we teach um, is guided by the answers my students will give as a result of an assessment. Assessments evaluates teaching programs. The different forms of assessment are standardized test, unit test, chapter test, lesson test, matching true false, quizzes, projects, presentations, writing tests. Assessment allows data-driven instruction through student performance data. Everything belongs to data. Now it's the era of data. We need data. Okay. So the assessment must be reliable and valid to allow conclusions. Must be reliable and valid. A few more examples. Two more examples actually. An 8th grade end of the year standardized test contains one writing prompt. It must be an essay. That's why the writing prompt. Two students in different classrooms produce similar responses that are comparable across all rubric criteria. One scorer assigns the first student the highest possible score of 100%. A second scorer assigns a second student a score of 50. Okay. Now, is this a problem with? Notice this sentence is the most important. Two students in different classrooms produce similar responses that are comparable across all rubric criteria. Both have fulfilled their rubric criteria, and both the results of both are comparable. But the second scorer has assigned almost the same test, 50, and the first has scored assigned the same test, 100. Now, is this a problem with reliability or validity? This is a problem with reliability. If the student responses are similar and comparable across all rubric criteria, the two scorers should have awarded the same score to the students. Instead, the scorers interpreted the responses very differently. A 5th grade geography teacher creates a test to assess the concepts in Unit 1 of the geography course. The goal is to determine if the students have met Unit 1's objectives. At the end of the test, she includes 5 questions that cover content from Unit 2 to appraise what students already know about the material. Is this a problem with reliability or validity? Now notice that she's trying to measure something that she hasn't taught the students yet. Okay. Validity. If the test is created to assess the objectives from Unit 1 of the courses, then content from Unit 2 should be excluded. Otherwise, the test itself is wrong. It's not valid. Now, this is the reference page. Thank you very much for listening in. I hope I didn't send you to sleep. Okay. Have a great day and never forget the diagram, the bullseye target diagram, and that little thing I kept harping on. If a test is reliable, it may or may not be valid. If a test is valid, it must be reliable.